to get through all before the we should be able to get through all before the end of the class session. If not, well, you know, we'll be very close to the end. I think we might just have to go like 5 minutes extra or something. So, right. So we are on item 16. This is now into module 2. We have the following scenario. A doctor is assigned one or more patients who are assigned to a specific ward. Attributes of a patient include their patient ID and information on their condition. So we know that attributes are represented as, you know, circles or ovals attached to an entity, right? The entities that we can see here are doctor for sure, ward for sure, and patient for sure. And I established because we were told that the attributes are ID and the condition of the patient. And the ward also has an ID. This one does not make sense because an attribute can't have a relationship with an attribute cannot have a relationship with an entity. So that one is out, right? So a doctor treats patient, a patient stays in ward, a patient has 2 attributes, ID and condition, and a ward has ID. So it looks like it could be B, right? Doctor treats patient, a patient has an ID and a condition, a ward has an ID. It looks like it could be C2 because there's a relationship between the patient and the ward and the doctor and the ward. And now we have to look even further and look at the cardinality, right? So we see here one doctor treats one patient. We know that even in the best healthcare system, there is no one-to-one relationship between doctor and patient. Everybody does not have their own doctor, right? And of course, a patient cannot stay in multiple wards, okay? So C, however, tells us that a doctor treats many patients and a patient is treated by one doctor. That makes sense. And a patient stays on one ward and a ward holds many patients. This makes sense. Let's just take a look at D, right? D has where the ward is an attribute of patient. That makes no sense. And a condition is not an entity. So the one that makes the most sense out of all of these, out of B and C, is C. So the answer here is C. Okay. Next we go on. Which of the following is not an attribute of a well-engineered software product, right? Software should be efficient, it should be maintainable, it should have appropriate documentation. The software does not necessarily have to be creative. Okay, so creativity is not an attribute of a well-engineered software product. Which of the following design processes refers to the identification of subsystems and their relationships? Subsystems and their relationships, architectural component, data structure, interface, right? The answer here is A, because in terms of architectural design is where the components, which are the subsystems themselves, are interdependent on each other. So you're looking at the overall architecture of the system. The component design is where you have like the individual units and, you know, its parts. So it's like discrete units where you design them. But when you start putting them together, you're looking at the overall architecture of the system. Okay? Data structure is just elements that holds information, and interfaces where the people interact with the system. One of the main weaknesses of the waterfall model is that what? The waterfall model itself is highly inflexible. Okay, remember the waterfall model, each stage must be absolutely completed before you go on to the next stage, and you're not supposed to go back, right? that is sorry, when you're not supposed to go back, that is the major drawback of the waterfall model. Which of the following are the essential features of well-engineered software? Right? All of these are so similar. It always gives me a issue to remember. So I'm going to pull up the features of well-engineered software. Right? So the attributes of well-engineered, properties of well-engineered software, and I'll just copy and paste it right here next to the question. Maintainability, dependability, efficiency, usability, portability, and availability of appropriate documentation. So it's right here next to it. So security is not one. Okay, so security is out. Okay, we have reusability is not one, right? Its usability is out. Okay, and user friendliness is not one. It's usability. So the answer here is B. Maintainability, which is here, dependability, efficiency, and usability. Okay? Not reusability, not security, not user friendliness. Okay? Answer D is kind of a, false friend, because you might say usability and user friendliness is very similar, but it's not what they are asking for. So what do I me yet? So any questions so far? Right, so the answer was B. All right. Okay. We're moving forward. 21. Which of the following graphical tools is best suited to show how software development project and its subtasks should be completed within a specific time frame? We know that answer is a Gantt chart. Okay, a Gantt chart shows us essentially the timeline for projects. When the individual modules of a software system were tested, no errors were detected. The individual modules. However, when all the modules were merged together and tested, the system failed. Which of the following would most likely help in identifying the failure? That is integration testing, right? Because acceptance testing is user testing. That should be once you get it internally working together as a system, if the user wants to accept the system. The testing individual modules was what they did initially, and testing using live data. It doesn't matter if they use live data or not, right? Even though you should not test using live data because you don't want to mess up the system's important data, right? Unless, of course, you're running something in parallel against an old system, but testing using live data will not help in this instance, okay? So it's integration testing where you want all of the components to come together and work for the system. Which of the following are examples of non-functional requirements, right? Non-functional requirements. Remember, non-functional requirements are things that the user desires for the system, right? So the user could specify platform constraints. They could say, okay, when I want the system to work on iOS and Android and Windows. Okay, these are the platforms that I wanted to work on. That's a non-functional requirement. That doesn't really affect the operation of the or the operation of the software according to the business rules. Response times. I need the system to give answers or responses within a specific time frame. That is a non-functional requirement as well. Okay. If it is that I see, if it is that the program now, because this is kind of like a non-functional requirement of, let's say, the iPhone. The iPhone worked, but at certain points it was presented to Steve Jobs. Steve Jobs didn't find that the motions on the phone was fluid. So those are things like response times, right? Reliability is a non-functional requirement. Okay, in terms of being able to specify, well, I need the system to have a certain amount of uptime, and fault tolerance is the ability to, of course, recover from any critical issues that happen so that the data isn't lost. Again, that is not something that is in the business rules. So the answer here is D. Okay, all of these are non-functional requirements. All right, Collins, shoot a shot on that one, but it was wrong. But what are we gonna say? You hit it. All right, so a small company with fewer than 10 employees is interested in replacing its existing paper-based system with a software application. All right. Which of the following is most appropriate for gathering information during analysis? Now we have fewer than 10 employees. Okay. Existing paper-based system with a software application. So in terms of gathering information during analysis, my issue with distributing questionnaires to employees and clients of the company, that makes sense. And interviewing key people at the company, those are two of the major answers that we will go for. I would like to run this question actually against or by some teachers, and hopefully one of them gives me the answer. I myself will go for the answer.
Oh.
See, I'm not quite sure what the software application does. Is it that the software application it impacts the client, or if the software application does not impact the client? So
yes, sir. Because I was thinking it doesn't make sense given the client's question is if
right. So I would go with D for now, but let me pass it by the ComSci teachers and and see what they say. And I will tell you all. But as far as it goes with me, I will go with D for my answer right now. Interviewing key people at the company. All right. Right. So I'll come back to this one. A company keeps information on its departments and employees, which of the ER diagrams below best shows the relationship between employees and departments. But this one, they kind of, instead of department, they put ward. All right. So just substitute the word ward with department. So is it a one-to-one relationship between employee and department? One employee works for many departments. One department has many employees, or one, right? D is just straight off because it does not answer anything about the question. So the answer here, the best one would be C, right? Where you would have one ward having many employees, right? Or one department having many employees, and an employee works on one department. So the answer here is C. So the software process model defined by its approach of refining an initial system based on user input is what? So if we have a system that gets developed and then we take input from the user,
So that's the
we take,
evolutionary development.
that is evolutionary development, yes. Okay. Which of the following might be output as a result of using a case tool, right? The one here that is most likely to be output of the result of using a case tool is going to be a prototype. Okay, because a prototype, of course, would be a piece of software. A prototype is going to be a piece of software. The cost benefit analysis, you might put that in, but is that really part of the software engineering? It might be part of the software analysis, but you have to engineer the prototype. Okay, you have to engineer the prototype. And 28, which of the following system models depict data transformation as data processed, right? That's going to be D, a data flow diagram. So you put data in and you show the processing of data and what comes out. Which of the following is considered a functional requirement? Okay, what is a functional requirement? What does the system need to function? We already established that response time is not a functional requirement from the previous question. The system needs inputs. The system needs inputs to be able to work. So very correct, Collins. Software evolution is doing what? Okay. Software evolution is where we, the answer here would be D. The answer here would be D, right? B would be more like software reuse. Okay. D is the answer here. When we modify the software to satisfy changes in customer and market requirements. Okay, so what I don't like about C is that we're automatically adapting software, right? So the process is not automatic. So somebody is going to have to go and change it unless you've written the software to automatically change according to the customer needs, which is borderline artificial intelligence. But D is modifying software to satisfy changes in customer and market requirements. Okay. All right. So we on to the last section. We have about 20 minutes. So you see the latter section of the paper doesn't really take long. Take your time to do the first 15 questions, please. Okay, take your time to do the first 15 questions. And the rest of the paper, typically the answers, you can work out the answer in less than a minute. In less than 30 seconds, actually. So, you can take your time, go through the paper, and still be finished well within the time. If a node fails on a ring network, what other stations are affected? Okay, we know that on a ring network, if you have nodes on a ring network, and our ring network uses a token to pass information, right? If we have a break in one, then the whole network goes down inside of the ring network. So all other stations are affected, right? If a node is no longer there on a ring network and the reconnection is not made, all stations on that ring network is affected. Item 32 refers to the cable shown in the diagram below, right? This cable here is a coaxial cable. We have our conductor, our insulator, right? We have our outer conductor and we have our rubber insulator to protect our cable on the outside. Okay, so this is like that cable that would provide TV signal to your house, or if you have cable internet, this is the type of cable that they're going to use. 33. 33 has another diagram, and we have a computer sending out a digital signal. That digital signal is converted to an analog signal via a modem, and then we have the modem converting that analog signal back to a digital signal so that another computer can understand it. This, yes, because modem stands for modulation, demodulator, right? Modulator, demodulator. So it's B. Which layer of the OSI model handles data transmission between host computers? If you're transmitting, if you're doing data transmission, then you are, right? Right. Yeah, if you are, sorry, yeah, if you are transmitting between two computers on the system, then you have that transport layer, right? Where you want to make sure that there's end-to-end transmission that is error-free. So you have the transport layer. We know that the network layer is responsible for addressing, right, and ensuring that we could find the route across the network. But the transport layer is the layer that will ensure that we get the packet to the other side, and if the packet did not reach, it will send a signal to ask for the packet to be resent. Okay, presentation layer deals with encoding, and application layer deals with the actual applications that that utilize protocols for the actual computer, like SMTP for mailing or HTTP for web pages or FTP for file transmission. You actually have applications that are utilizing these protocols. Which of the following is not a method of securing files being transmitted on a network, right? If your files are compressed, that's a way of securing the files because it makes a large or plenty files. It compresses them into one single file, which is smaller than the amount. So there is there's less chance of an error of data falling off. So compression is a way of securing files. Encryption makes the files unreadable. So unless you have the decryption key, so that is a way of securing files. Only the sender and the receiver should be able to decrypt. Passwords will lock somebody out from accessing the files, but firewalls are used to prevent unauthorized access to somebody's computer on a network. So the answer is C. Firewalls does not have anything to do with transferring files across a network. Which of the following best describes paging, right? Is it the division of documents into smaller chunks? Well, they don't really mention anything to do with memory there. The assignment of chunks of a program called frame, chunks of main memory called pages, the assignment of chunks of a program called frames to different secondary storage media, or the assignment of chunks of a program called pages to chunks of memory called frames, right? I'm gearing towards D here, right? Because I don't really like how they say memory inside of here. Let me just pull up my, oh my God. All right, hold on a second. So I'm going to go with D, but I'm going to go with D and give this a quick check. Okay, just to make sure that the chunk of memory is called the frame and the chunk of the program is called pages. I know that the data itself is called the pages, but I just want to verify that the chunk of memory is called the frame. So what are the layers of the OSI model in order from lowest to highest? Anybody could tell me this one? We know we have our pneumatics. Right? Mnemonic, sorry. Did I say pneumatics? What is our mnemonic? Let me see. Question 37, people. We know that we have plenty dogs need to secrete pee always, right? Plenty being physical, dogs being data link, need being network, two being transport, secrete being session, P being presentation, and always being application. Okay, the lowest level is the physical level. So the answer is C. Thank you. Was that correct?
Yes, sir.
All right. Okay, yes. So the physical memory is broken up into frames, and the chunks of the program are pages. Okay, so the answer is D, right? The chunks of the program are pages, and the chunks of the memory are called frames. No problem. Which of the following is the best reason for compressing a file? Right? Which of the following is the best reason for to compress a file? We want to compress a file. Let's see, to encrypt the file. No, we're not going to compress a file to encrypt it. To make the file compatible with other applications. No, that's not the reason for compressing a file. To increase transmission time over a network. This is a trip-up answer. Compressing a file will decrease transmission time. So the answer is actually D, to occupy less space on storage media. So sometimes in a computer system, when you have limited space, or you want to save space and you have files that might not be accessed very often, after a certain amount of time, files are compressed because they're not being accessed as often to occupy less space on storage media. So this answer C is a trip-up answer, because we just saw something like that in terms of transmitting and compression being probably an answer there, right? But the answer here would have been to decrease transmission time, not to increase. So look out for these tricky questions. Which of the following best describes an absolute file path? Okay, let me give an example of an absolute file path on a computer system. So I'm going to take a little screenshot of my computer here, and I will show an absolute file path as an example, right? Ooh, hold on, I have to take a screenshot and then cut that screenshot. Okay, so give me 1 second, and I will put in that example of that absolute file path. So we have here, if you see it on my screen, a picture, and inside of this picture we have an example of an absolute file path where we see D downloads, organized IT past papers, and then we have folders inside of there. That, if I wanted to get to this January exam folders on my computer, I have to go to this specific path on my computer. That is an absolute file path. That path is where the files are on my computer system. Okay, if it is that I wanted to, say for instance, reference a file from another file's location, then I could reference that path relatively to where that file currently is. So a relative file path is something like if on my computer system, I have my C drive, and then from my C drive, right, I have different folders. So I have like F1 as a folder, and then I have, F looks like a 7, sorry, right? B2 as a folder, and inside of B2, I have some files, right? A1, A2, and A3. An absolute path to A1 is going to be C colon backslash B2 backslash A1 or A2 or whichever file. But if I wanted to get a path relative, right? Let's say, for instance, I had a file outside here, right? I had a file outside here, and this file was E1, and I wanted to reference E1 from A1, right? I wanted to reference E1 from A1 from inside of A1. Inside of A1, I could put dot slash E, right? Sorry, actually dot slash E1 or something similar. And what this is going to tell me is that it's going to tell me go out of this folder, or from this folder, go out of to the main folder and access the file that is outside of here. I may have botched this a little bit, right? Because I can't remember my relative file path. But what I'm saying is that this is only accessible from this specific location. If I were inside deeper, I would have more dots to come out of. Okay, but the thing is, if I wanted to absolutely access a particular file, then I could always see where the file is located from the root address. And this is the root address, right? So we know that in terms of addressing on a computer system, it's like an upside down tree. Okay. And yeah, so the question, the ComSci teachers do agree with me. I'm going back to the question with the interviewing key people at the company, right? Interviewing key people at the company. That is the answer that most teachers yeah, right. That's the answer that most teachers agreed with. So just to let you all know, interviewing key people at the company is the accepted answer, right? Because of the size of the company. Okay, so which of the following best describes an absolute nice file path is going to be, right? It explicitly identifies all the elements to locate the file, right? Including the disk name. So the answer is D, right? If you exclude the disk name, it might still be relative. Okay, relative from one file to another. Which protocol is used by web pages to transmit information? We know that HTTP is that hypertext transfer protocol for web pages. Which IEEE standard can be employed when setting up a wireless LAN for wireless devices needing transfer rate greater than 20 megabits per second, right? A was a 5 gigahertz network. I think it had more than 20 megabits per second. B was a 2.4 megahertz, which did not give you the speeds. G was an improvement on B using 2.4 megahertz that met the 54 megabits per second like A. So my answer here, if I remember correctly, is going to be D. Right? G and A has the same speed, and I believe that both of them are 54 megabits per second. Which of the following is true about a process being scheduled with a non-preemptive algorithm? What is a non-preemptive algorithm? A non-preemptive algorithm does not allow for the process running to be finished early. So if it's placed at the top of the ready queue, if it has a higher priority than all of the processes, no, that doesn't have to happen with a non-preemptive algorithm. Once it enters the running state, it's allowed to run to completion or until it yields the processor. This seems true, so B seems likely. Once it enters the running space, it's given a fixed amount of time. No, then that becomes preemptive, right? Once it enters the running space, it's given a variable amount of time to use the CPU depending on its priority. No, it's not fixed or variable. It is that it must run to completion until it decides to give up the processor. All right. 43, a client suspects suspicious activity on his network which contains computers that frequently access the internet. Which of the following should he implement? The key word here is suspicious activity. Okay, so to see what's going on, right? Not in terms of which contains computers that frequently access the internet, right? If he wants to prevent that suspicious activity, I will go with firewall. Okay. If it is that he wants to, how could he find out if there is suspicious activity going on? He would have had to check the activity logs. Okay. Which of the following determines the amount of time a running process gets to use the CPU when a round-robin scheduling algorithm is used? Okay, in a round-robin scheduling algorithm, right, the time is fixed by the operating system. So the operating system says everybody gets a certain amount of time. And the last one, a running process initiates an input request to get data from the keyboard. Which of the following state transitions will take place when the data is made available? So when the data is made available, okay, which means that the running process has to go into blocked, right? So the running process has to go into blocked until it gets the information from the keyboard. And then when the information becomes available, then it goes from blocked to ready, right? So it goes from blocked to ready. So the answer is C. Any questions, folks, before we finish off for today? Any questions before we finish off for today? All right. So that's it for us for today. I will post the answers to this in this channel chat. And of course, I will work on Alexa posting up the videos that I did have. Okay, let me just take the roll one last time. I'm going to stop recording now.